Alright, so what we're going to do, we're just going to do one example of a sketch. So, let's sketch the function y equals okay, so y equals x, take 3x, take 5, and x plus 1. Let's do that one. Okay, so that's a cubic, obviously. What we'll do is we'll expand that out. So we get x squared, take 5x, take 3x, plus 15, and x plus 1. So we end up with, well, that's x squared, take 8x plus 15, with x plus 1, which is x cubed, plus x squared, take 8x squared, take 8x plus 15x plus 15. I hope that's right. That would be embarrassing if it was wrong. X cubed. So we have x cubed, take 7x squared plus 7x plus 15. Does that look right? Yeah. So worked out okay? Okay, so we want to, when we're sketching, we need a few things. So I had a checklist somewhere. Here it is. Okay, so these are the things we need when we're sketching. We need our x-intercepts, y-intercepts, stationary points, nature of the stationary points, extremities, and is there anything else? Concavity. We're going to leave concavity for a different example. I think this is it. So that's all we need on this sketch, really. We'll do, we'll cover another example with concavity. Yeah. Okay, so just for sketching, well, let's start off with the y-intercepts. How do we find y-intercepts? Let x equal 0. Okay, so we say, well, y is equal to 0 take 0 plus 0 plus 15, because if all these x's are 0, we're left with our 15.
So don't we need the y dash?
Oh, yeah, we do. Yeah, let's, okay, so y equals 15, come back to that, sorry, yeah. So what's our y-intercept? Is that our y-intercept?
Yep.
We have to write the whole coordinate. Okay, so that is not the y-intercept, that is the y-coordinate for the y-intercept. So the y-intercept is 0, 15. So that is the coordinate where we cross the y-axis. Is that, you guys can read that okay?
Yeah.
Yep, okay, great. And then we'll do our x-intercepts next. How do we find our x-intercepts? How do we find our... Thank you, let y equal 0. So we have, now which function are we going to use?
Y dash.
Y. Okay. We're going to use this one or this one? So these are both the same function, but which one would be easier to solve for? The top one. Okay. So if we say 0 equals x take 3, x take 5, x plus 1, what can we use to solve that? Yeah, we can use the null factor law. Yeah, the null factor law. Okay, so because we have this already factorized, we can say, well, x take 3 equals 0, x take 5 equals 0. Sorry?
You know how it's 3, we made it to 2, and then we made it to 1. Yeah, we still have 3 x values.
Yeah. Okay, so we've got x equals 0, x equals 5, and x equals -1 for our 3x values. It is x equal 3. Just checking you're all awake.
We are. We have the Monday.
Good. At least one of us is. So our x-intercepts, now remember these are the x values for our x-intercepts, so we have 3, 0, 5, 0, and negative 1, 0. Okay, so we've got our x-intercepts, we've got our y-intercept. Okay, so that's our first step. What else do we need to find?
Stationary, no. Derive a type.
Well, we need our stationary points.
But we need to derive a type first.
Okay, so let's come back up here now. Yeah, one thing that I forgot to do that I would normally do straight away is find our derivatives. So we would straight away find, well, y dash is going to be 3x squared, take 14x plus 7, and y double dash,
6x minus 4.
take 14. Okay, so we have, for our stationary points, how do we find our stationary points? Let y dash equal 0. So we have 0 is equal to 3x squared, take 14x plus 7. Now, how am I going to solve that? Okay, how do I factorize? How do I solve that? I could factorize it. I don't know if I want to factorize that. ACA. Quadratic formula? It might not work with this one, because I just came up with it on the spot. So let's do the quadratic formula to solve it. So if this is my A, my B, and my C, then x is going to be negative b plus minus root b squared, take 4ac over 2a. So that's 14 plus minus root 14 squared, take 4 by 3 by 7 over 2 times 3. So we've got 14 plus minus, okay, 14 squared is 100 and something, 78? 96, yeah, that's what I said. 196 take, what's that, 84 on 6. 14 plus minus 196 take 84 is going to be 112 on 6. So we have our two stationary points occur at x equals 14 plus root 112 on 6 and x equals 14 take root 112 on 6, and if I could get some values for these, some decimal values, as we are graphing it, it's good to have a decimal value. So both of these worked out. 14 plus root 112. Sorry, think 24.69, and for the other one? 0.56. Okay, so we've got our two values for our stationary points, our two x values. What do we do with those values? Did we make a mistake? Which one? So this one should be 4. 0.9? No. So thank you. Okay, so we have our x values for our stationary points. Where do we go from there? We need the y value, and we also need the nature. So we need the y value of it, so we need to know what the actual whole point is. We also need to know whether it's a max or a min. So I'm going to do this I'll do this once for each thing. So I'll just rewrite my functions. So I've got my y is x cubed take 7x squared plus 7x plus 15. And my y dash is 3x squared take 14x plus 7. I'm just rewriting them down